Right, we're now going to do the chain rule or the composite rule in calculus. Right. Now, the first thing I'm going to do is show you how we replace x with another function called g of x. Compare, for example, y equals x to the power 5. If I then write a new formula, y equals sine x to the power 5, what has replaced x? In the second one, sine x has replaced x in the first one. And so sine x to the power 5 is said to be a composite function, as it composes of more than one function. It is a function of a function. So just note there as well that I've also shown you another way of writing sine x all to the power 5. That's the sine x that's raised to the power 5, not just the x. That is also written as sine to the power 5x, with a 5 in between the sine and the x. That's just the way we write it. Okay, now how do we differentiate composite functions? Well, let's have a look. If I want to differentiate x to the power 5, y dashed, which is the derivative, dy dx, same thing, is put the 5 in front and reduce the power on x by 1. So you get 5x to the power 4. All right, now how do I do sine of x to the power 5? All right, let's write it like that, sine x to the power 5. Here's what we do. Put the 5 in front, write down the sine x, just like I wrote down the x, put power 4 on, reduce the power by 1, and there's going to be an extra bit. I'm going to multiply by something, but what is it? So the question mark is, we need to multiply by the derivative of whatever has replaced x. And so you've got to try and see what has replaced x. And this is the extra bit that the chain rule does. So what has replaced x in this case? Well, you've seen it's sine x. Let's differentiate that. Yes, cos x. So now we've got it. If y is sine x to the power 5, y dashed, and every time I say y dashed, you know I mean the derivative. That's 5 sine x to the power 4, and in that space goes the derivative of what replaced x, and the derivative of sine x is cos x. So the answer is 5 sine to the power 4x cos x. All right, so let's try these 4 examples there, see if you can do them, or just try the first one and come back to me. Right, this one's cos of 5 to the power 5x, or cos x to the power 5. So let's differentiate. Y dashed, put the 5 in front. Cos x stays there, power 4. And now differentiate what? Yeah, differentiate the cos x, because that has replaced the x. And you get minus sine x. So final answer is, let's collect them together, minus 5 cos to the power 4x sine x. Right, now you try the others and come back to me for a chat. All right, number 2. Here, what has replaced x? Well, it's x squared plus 3x. Right, so put the 5 in front, differentiating. Write the x squared plus 3x to the power 4. And now differentiate what's replaced the x. It's a whole formula this time. X squared plus 3x has replaced the x. If you differentiate that, you get 2x plus 3. So I've got to multiply by that. In the third one, you put the 5 in front again. You keep the ln x there. Power 4. Differentiate the ln x. You get 1 over x. And that is what you multiply by. The derivative of what replaced x. So the final answer there is 5 ln x in a bracket to the power 4, all divided by x. And then finally, that tan to the power 5x. 5 goes in front, tan to the power 4x. Exactly the same as I did for sine and cosine. Multiply by the derivative of tan x, as that has replaced x. And you should know that the derivative of tan x, you can check your formula sheet if you haven't, is sec squared x. So the key to all this, what has replaced x? It will also be a formula with x in it. So let's call it, say, g of x. Whatever happens to x in its y dashed calculation, do the same to the g of x, which replaced the x. And then when you're finished, multiply by g dashed x, which is the derivative of g of x. And you've got it. Okay, so if g of x replaced x in my x to the power 5 example, let's use g of x in that x. Let's use it here and see what it looks like. I'd have y equals g of x all to the power 5. So what's y dashed? Put the 5 in front. Keep the g of x. power 4, and multiply by the derivative of g of x, whatever it is, and let's call it g dash x. All right? So that's just using x to the power 5. Obviously, if I use x to the power 4 and x to the power 7, all power functions work in a similar way. But let's look at a few other functions as well now. Right, here's e to the power sine x. I'm going to differentiate that. Well, it's not e to the x anymore. If it was e to the x, y dashed would be e to the x. It wouldn't change. So sine x has replaced x here. So do to sine x what you did to x. In other words, you just didn't do anything. You just left it. But you must then multiply by what's replaced x. So I've got to multiply by the derivative of sine x. Here we go. Y dash becomes, just write down what you had, e to the sine x. That's what I did with e to the x. I just wrote down e to the x in the answer y dash because that's its derivative. But the extra step here is the chain rule because sine x has replaced x. So I multiply by the derivative of sine x, which is cos x. So the answer is e to the sine x cos x. So a general rule based on this function y equals e to the x would be, if I've got y equals e to some function of x, e to the g of x, say, y dash becomes e to the g of x. Don't change it. Simply multiply by the derivative of g of x, which I'll write as g dashed x. Okay. Right, let's do some other types of functions here and then write down the rule. Try a couple here if you want to, see if you've got the idea, and come back to me. Right, in number 2, I've got sine 2x. So what happened here first? Well, x was doubled and then was signed. So the sine is, if you like, the mother function that's working here. It's the last thing that happened. So that's the one I've got to concentrate on first. So differentiate sine 2x, you'll get cos 2x. But I've got 2x, not 2. Not x, I apologize. So differentiate the 2x, you'll get 2. So the answer is cos 2x times 2, which is 2 cos 2x. All right? Number 3. Y equals sine x squared. Well, the last thing that was done there was the signing of the x squared. So the differentiate, you'll get cos of the x squared. Okay, because the derivative of sine x is cos x. The derivative of sine x squared is cos x squared. But the extra bit is to differentiate the x squared. So you multiply by 2x. Okay, and that you put in front of the cos x squared. Don't multiply the 2x by the x squared. It's the whole of cos x squared that's got to be multiplied by 2x. So I put it in front. And there's your rule in the block. If y is sine of g of x, y dash becomes cos g of x. And then multiply by the derivative of g of x, which is g dash x. Okay, number 4. Y equals 2 cos 3x. Now I've got a number in front of the cos 3x here. No big deal, it stays there. Y dash becomes 2 sine 3x. But I've got 3x, not x. So differentiate the 3x. You get 3. And I need to multiply the 2 sine 3x by 3. And that lands up with 2 3s are 6 sine 3x. The 3 goes in the front. Okay, don't multiply the 3x by the 3. Multiply the sine 3x by the 3. Okay, you try number 5. Okay, y equals 3 cos x squared plus x. Y dashed will be 3 sine x squared plus x. Differentiate the x squared plus x, you get 2x plus 1. Put it in front, 3 brackets 2x plus 1 times sine x squared plus x. And look into the block and make sure you're happy that you can write down the rule that you've used and check it with mine. All right, number 6. Y is ln sine x. Well, how do we differentiate ln x? Well, the derivative of ln x is 1 over x. So the derivative of ln sine x is 1 over sine x. And now differentiate the sine x, so you must multiply by cos x. So you can write that as cos x over sine x. You should recognize that, in fact, as being cot x. Okay, sine x over cosine x is tan x, then cos x over sine x is cot x. Okay, and there's your rule. Y equals ln gx. Y dash becomes 1 over gx. Okay, and don't forget to multiply by the derivative of gx, which is g dash x. So you'll end up with g dash x over gx. Try number 7 and 8 and see how you get on. Right, number 7 was the same, similar as number 6. You're going to get 1 over x squared minus 5x. you need to differentiate x squared minus 5x and multiply by it. So it lands up on the top of the fraction. You get 2x minus 5 all divided by x squared minus 5x. Number 8 is not an ln example. You need to rewrite that as x squared plus 2x to the power of minus 10. Correct, because it's going to the top. Now that becomes a power function type. Put the power in front, you'll get minus 10 x squared plus 2x. Reduce the power by 1. Minus 10 minus 1 is minus 11. And now you need to differentiate the x squared plus 2x. You get 2x plus 2, and that's what you multiply by. All right. Even examples with longer chains in them, you should be okay. So look at this one. Can you differentiate sine x squared, as in example 3? Right, by the chain rule, you saw that you got cos x squared times 2x. So you've already done that one. So let's all just agree, yes, I can differentiate sine x squared. Okay, now you're going to need that, because in this next example, look what we've got. Y equals e to the sine x squared. Find y dash. Now this is a composite function of a composite function. It's a function of a function of a function. Let's not get too entangled, but here we go. Reminder, if y is e to the x, y dashed is again e to the x. So step 1, if y equals e to the sine x squared, y dashed is initially e to the sine x squared. But I'm not finished. I need to differentiate sine x squared. And you've done it. You've done it on the previous page. It's cos x squared times 2x. So you'd simply say, I need to differentiate the sine x squared. Oh, but it's already a function of a function, so it becomes cos x squared, and I differentiate the x squared to become 2x. So it's a double chain. All right. So see if you can try those couple there on double chains. Come back to me. Right, the first one, y equals sine squared 3x. I rewrite that as sine 3x all squared. So now it's a power function. Y dash becomes, put the power in front, 2 sine 3x all to the power 1. Aha. But it's sine 3x. Okay. It's not x, it's sine 3x. So I need to differentiate the sine 3x. That becomes cos 3x. Oh, well, it wasn't cos x. Okay, it's cos 3x. So I need to differentiate the 3x to get 3. Put the 3 right in front. You get 6 sine 3x cos 3x. Right, look at the next one. Cos e to the 5x. The last thing that happened there was the cosigning. All right. So that's got to be done first. The derivative of cosine is minus sine. So it's minus sine of whatever you got in the bracket, which is e to the 5x. Now whatever you got in the bracket needs to be differentiated. How do you differentiate e to the 5x? Answer, e to the 5x times 5. You must multiply by e to the 5x first, and then differentiate the 5x to get 5. Okay. Right, now there are other ways of using the chain rule, and somewhere in your travels you may see the notation dy dx, dy du, du dx notation. So I'm going to show you how to do it using that notation here. So if y is e to some function u, e to some power u, and u is itself a function of x, then in effect I would actually have y as e to the power sine x. If you just replace that u with what it is, which is sine x. If you differentiate it, then you would get y dashed is e to the sine x, just repeat it, and then differentiate the sine x to get cos x. But I'm not going to do it like that here. I'm going to show you that we could actually do it using this formula. We can use this version of the chain rule, which is dy dx is dy du, du dx. So differentiate y with respect to the link, which is u, and then multiply that by the link differentiate with respect to x. Let's check how this works. So let's start off. The first thing I'll give you is y equals e to the u. Now all I can find from that is dy du. Dy du is e to the u. And the next part I told you, the link at u, was sine x. All I can find from that formula is du dx, and that is cos x. Right. So now you've got dy du and du dx. and I'm wanting dy dx. So you've got 1 and 2. Here we go. Dy dx, according to my formula, is 1 times 2. Formula 1 times formula 2. Okay, which is dy du times du dx. You can imagine those two du's, if you put your fingers on the two du's, they could actually cancel, if you like, in your head. They don't really, but you can imagine them cancelling, and you'll end up with dy dx. So it's a way of remembering the formula, if you like. So dy du, let's copy it. That's from 1 becomes e to the u. And du dx from number 2 becomes cos x. So there's my answer. But let's put the u back in. What is u? U is sine x. So stick it into the right-hand side of that formula, and you'll get, finally, dy dx is not e to the u anymore, but e to the sine x times cos x. And that's what I got before. Right, so see if you can do that last question there for me, and then come back to me for a quick chat. Right, so y was u squared. So straight away, all you can find from that is dy du, and that is 2u. Put the 2 in front, reduce the power by 1. U was cos 2x, be careful. This is a chain rule again. So du dx is sine 2x minus sine 2x times 2. And that's why I've put the minus 2 sine 2x there. Right, so if I'm going to multiply those two results you've got your answer. So dy dx is dy du times du dx, and that's simply the 2u in the first question times the minus 2 sine 2x in the second part of that. So in the first question, the first equation, y equals u squared, times the second one, which was minus 2 sine 2x. So it's a product of those two. But what was u? U was cos 2x. So just replace it on the right-hand side there. You get dy dx equals minus 4 cos 2x times sine 2x. And how did I get the minus 4? From the 2 times the minus 2. All right? Right, you've got quite a few examples to try in your exercises. This is a very important section on the chain rule. This is very important. You must know how to do the chain rule, because that will help you do all the examples in the product and the quotient rule to come. And it's a skill you need to master. So make sure you try all the examples and you check your solutions, okay? Bye for now.